Hello everybody. Again, it's a pleasure for me to speak here at TCT in Japan and have the slot to present AMCM products here in the show. So my agenda, I will tell a bit about AMCM, some facts and figures, and about our system portfolio. And most relevant, I think, the latest products. Also our markets and some case studies, which are also on display here at the show, and our innovation focus. So where we are, AMCM is part of EOS Group. So we are independent sister company, 100% owned by Langer family. Our team came from, let's say, different companies. About 50% of the team worked at Rofin Basel for many years. So they are laser and scanner specialists and have a background in automation. And the other 50% are from EOS. So they have additive DNA, like me. And we have some colleagues which also have developed at EOS, for example, EOS M400, EOS M100. So we have R&D colleagues in our team which have a lot of experience. How was the history? Maybe I start even earlier. In 2016, there was a trade show and Dr. Hans Langer asked Martin Weilhammer, so our today's boss, he worked for EOS at that time, and he said, when do we do the machines which EOS don't produce? Because they're too exotic and they don't fit into the Syria portfolio. And then Martin said, I have an idea, because he worked also for this laser company and he had a network and founded a startup. So in 2017, that company was founded. Already 1 year later, we proved to make a 1 meter high aluminium part. Aluminium is not as relevant for space, but already in 2019, the first copper chrome zirconium part with 1 meter was built. And in 2020, we also could already deliver first M290 dual FDR, which is used for medical application. FDR stands for fine detail resolution for computer tomography, and also the first M4K, the 1 meter machine, was delivered. And so it was constantly growing. 1 year later, it was already 10 M4K installed. 2022, we get a funding for even a bigger machine, M8K. And 2023, we had our first N-Light system at start for beam shaping. And this year at, or let's say 2024, last year, we had the first part on display at Formnext, and we were very proud, part is over there on our booth, that we could demonstrate that also bigger additive manufacturing parts in copper chrome zirconium are possible. A bit about facts and figures. So meanwhile, we have 136 machines installed worldwide. So you see a bit of split. Biggest is North America, but also in Europe is quite a good market. And also 22 in Asia and 2 in Australia. And all these 136 machines would not exist if Hans Langer didn't give us the chance to make a startup. And just to have a ratio, EOS sold 5,000 additive industrial printers so far. And the first year was hard. And from that point on, we had a good story. So based on these 2 business cases, which was space and medical, we could make good numbers. And just to give an idea how the last year was, in machines, we made 34 machine delivery. And these 34 are 24 M290 variants, 3 M450s and 7 M4K. So that is let's say, our last fiscal year. Where we are located, we are in Starnberg, 20 kilometers away from Munich, and close to EOS, maybe 15 kilometers away from EOS site. We have a 5,000 square meter production site. So there we can do production in parallel of, let's say, 12 M290s, 4 M450s, and 4 M4K, sorry, and 2 M450. And this is where we have our production slots, machine next to each other. We produce them in teams, and our size of employees is 89. We are a very technical team, so a lot of engineers for R&D and also for production. We have 7 project managers, we have application team, we have 6 service technicians which install the machine worldwide. We have also a software team because customized machines also sometimes need an adaptation in software, and also about logistic, exports, and also quality, purchasing, controlling sales, what every company needs. But our benefit in this network with EOS is we can also use shared services from EOS. For example, IP or even support from EOS service worldwide can be used because we are part of this EOS ecosystem. We plan to find a new site because you might have seen we have a big part. That big part needs a big machine, and to assemble big machines our site is much too small. So we will move in 2027 to a new site where we are able to place or produce up to 4 M8K at that site. This is a production space for M290s, M450s, M4K, and that is our application area. So just caused by that bigger machine, we also have to upgrade a bit our infrastructure, and that facility is about 7 kilometers next to EOS site in Kralling. Yeah, then a bit about our portfolio. Maybe a bit definition first. So maybe in English, tuning, customizing is a bit mixed. What we call tuning on left-hand side are machines which looks more or less like EOS machines. From outside, you don't see a difference. Maybe they have stronger lasers, maybe they have a bit bigger envelope. They have a modification, what we have done to fulfill customer needs. On the right-hand side, we have machines which at least have a big, maybe a bigger lid, or have a completely different face like the M4K, but inside are still modules from EOS or software from EOS. And this is what we call customized. And you can see in the numbers, it's about 50-50 split. The left ones are less changed, let's say like that, and the right ones are more customized. And the deal with EOS is, as soon as a machine variant, like the M290-1 kilowatt, passes a special threshold, maybe 20 or 30, then EOS can decide to take over that machine in their portfolio because it's maybe relevant for them. If it stays exotic, so for example on the right-hand side there is this M290-2 FDR for tungsten anti-scatter grid production, then also EOS can say, this is too exotic, keep it. So it's good for customized machinery, and that is your job. And what we call small series are machines which we have in a portfolio and we sell it more often. So it's M290s with 1 laser, -1 means 1 laser, or -2 means 2 laser. These lasers could be 400 watts, kilowatts, or with N-Light laser 1.2 watt, 1.2 kilowatts. And same with M450 and M4K. So we can do different variants of laser in that machine, and also other equipment. I will come to that, like heating or other features. Very special feature is that N-Light laser with beam shaping. So from my point of view, beam shaping with N-Light laser offers just one additional parameter. but from my perspective is the most important parameter. You can control the beam size. You can really control the energy distribution, and that makes the difference. You see it here on that animation in a very quick way. Inside the laser, the shape of the laser is formed, whether it's a Gaussian or whether it's a donut form, and then a bit like on milling machine, you have a finger miller or you have a big milling device to make fine or big treatment. Same here. And you can utilize the laser energy much more efficient than just having a constant Gauss laser. And the laser power is stronger than the others what we use currently. So even in the best conditions, up to 1200 watts can be used. So here a short video. Here we go. Doesn't want. Give me a second. Now it starts. So on left-hand side, you see a standard process with, let's say, 280 watts, and which is a 400 watt laser. But even for a 400 watt laser, you cannot utilize the full energy because the spot is so fine that it would vaporize too much material. On left-hand side, the energy is much better distributed, and it even has a optimization for smoke reduction. So you can hardly see that 295 watts compared to 700 watts makes a big difference. And then the productivity, more or less for every powder, could be at least factor 2, factor 3 higher, just with that tool, beam shaping. And the range is from 85 micron standard left to 210 micron in donut size. So meanwhile, we have 15 systems sold. As I said, we can equip all our machines with Enlight laser. First customers start with a single, so universities, but also OEMs. We also have a dual in our portfolio with full field overlap. There is already 7 systems sold. We have a so-called M290 FLX. FLX stands for flexibility, FDR for fine detail resolution. This machine has a very fine spot from 55 to 140 micron. So you can make very fine structures, but also thicker ones, both in one machine. And additionally, we have other 5 systems in our R&D or at EOS site. And last year, there was already the first user meeting. Customers, the university, running such machines, sharing their know-how and wanting to push that market because they see a very big potential. So, next about latest products. We are happy to, let's say that AMCM won a tender, a funding from Ariane Space, a German aerospace and space agency, DLR, and they gave us money to make a XXL AM system because European Union want to be independent in, let's say, capabilities, bringing satellites in space or having navigation satellites, telecommunication and defense with our own resources. This machine, what you see here, is a prototype. It looks a bit different than the design what we have on display, but it has the same hardware inside. It's a large size machine. Out of our learning from M4K and other customized machines, we just add these and made a machine which has now size of 160 millimeter part. So platform is a bit bigger. And the footprint is already in the range of 14 meters 5 and 4.5 meters high. So if somebody wants to make us a machine with 2 meters Z-axis, it might be a bit higher. But this is what we do as customized machine. The machine is equipped with 8 lasers. We can do kilowatt. So current machine has 8 times kilowatt on board. but we can also make 8 times N-Light with beam shaping as I showed. Availability is planned for mid of next year, Q3 2026. Benchmarking can start right now. We are quite busy with, let's say, our funder like Ariane Space. They booked more or less the next 6 months the machine. So we expect that in 2025 we run only copper chrome zirconium on that machine. And 2026 we will change to Inconel 718. Just to give an idea, for the first filling of such a machine, you need 5 to 6 tons of powder. And also to generate the task file could also last 1 to 3 days just to calculate this big amount of data. And just a number, it's 14 times the envelope of a EOS M400, what you have in that machine. Yes, there we come from, EOS M400. This is, let's say, the most relevant topic to make bigger machines. You have to get the flow under control. So it's easy to plug a lot of lasers and scanners on a machine and make a big envelope. But if you cannot remove the process side products like soot and splatter away, then you won't get a good part and never a process to build a part. So we learned over the years. First it was a kind of laminar flow, right to left. Then it was from top down, like a shower on M400-4. Recently we optimized on M4K, let's say top down and side, because it's all about removing the dirt. If you make taller parts, like 1 meter part, you have to remove the dust more efficient just to avoid that during a long job, dust is blocking the protection glass. And for a M8K with 8 lasers and even 1.6 meters, you have to make sure that there is no effects, no pollution on the optic. Next is our thoughts about scan fields. As I said, you can plug a lot of laser on such machine. We decided just to do 8 lasers. Powerful lasers with big scan fields. So 450 to 425. The idea is there we can do a better load balancing. So neighbor lasers, neighbor scanners can support each other and you can split the load to these 8 lasers. There is never a laser lazy. They are all work. And even scan fields which are not neighbors, like here number 2 and number 4, have an overlap. So we made a lot of calculation and saw whether it's a cylindric part or whether it's a rectangular or asymmetric or many parts, this has big benefit. Then, having a big machine, you also have to think about filter system, because we want to recycle our process gas and we want to get rid of the soot and condensate in the process. So we made a big filter system with particle separator. We have 3 permanent filters designed for very long jobs, and also an innovative oxidation unit which makes a passivation of that condensate during process. So you do not need any chalk or sand or silicone to passivate the powder. It is oxidized during that process. So it's de-risking for the operator handling the waste, and it's also reducing cost because you don't need this additive to passivate it. Next, if you run a lot of scanners and lasers, you need a lot of cooling. You have to control that setup, and you have to make a thermal decoupling of that optical element, optic bench, with a process chamber, with a X-frame, the frame underneath. So there is a special design to avoid that it heats up. And we also have a lot of sensors in the machine to keep the process conditions constant. As well as monitoring, we have 2 powder bed cameras in there to cover the envelope, and we need 4 OT cameras and need to stitch these 4 pictures in one. And for closed loop, we have to handle 10.5 gigabyte per second just to make a monitoring. So that's relevant here. And also short movie. how the 8 lasers are dancing. So that is one layer of the part, what you see on display on Xam's booth. So that is perfect load balancing. Then I come to the other innovation, which is a new M290 with dual N light. I would say the most powerful M290 version so far. It has 2.4 kilowatt laser power. It has the benefit that it can take existing EOS parameter and use it, because in the mode 0, it has an 85 micron spot. And the machine also can be equipped with special features like heating up to 500 degree or active cooling. I come to that. So we have developed special platform carriers with 200 degree, which is standard already now, 500 degree build volume reduction and also cooling. So that is how a platform carrier looks like in a machine. And you can replace this unit quickly via operator, maybe in a kind of minimizer. Smaller envelope, 100 millimeter diameter, heating, suitable for R&D, for testing. And you can change this device if you don't need it any longer, then you use the big area again. So this is the area where you can expose and make your tests. We also made a platform heating because it was demand for some customers already with up to 500 degrees. And you see in the corner it's a bit colder, so we recommend a building area of 220. And also here, if it's not needed because you run another material, then you can take it out and put in a different device. Some of the alloys from EOS and others have been tested, and we have seen that they benefit from these higher temperatures. And for example, aluminium alloys or these PL26, which is for turbochargers and high resistant material. But it could be also the other way around, that the process is getting too hot because we have more and more laser power and the parts have a good heat conductivity, so we need to cool it actively. So we also have an insert with cooling. Having a part like this tree form now, it's very difficult to get the heat out of the part. So what might happen when you produce copper? You see a lot of copper parts here on the show. It looks easy, but copper can make trouble. So at the top end, you have these dots here on powder bed. When you remove the powder, you see there is agglomerations, and then the powder is quite agglomerated, sticky. So here, a defined cooling and also some closed loop monitoring can help to reduce that effect and to have better properties in your copper parts. How does it look like? In your machine, you have a socket where you plug in these carriers, and these are ready to take the water connections, the power supply, and even sensors. And in detail, these two big ones are for the water. This is power supply and sensors. We can do up to 15 variants. And if you plug it in, it automatically detects what device is now active, and you can switch from heating to cooling more or less full automatically. Some of the devices are a bit more heavy. There you need a crane to take it out, but two of them can be also lifted by humans directly. So they are just 20 kilograms. Maybe short. Yeah, I jump over the video. I think there is maybe so quickly. Yeah, I think we can make it. So you open 4-6 screws, which lock them in the machine. And then you add handles. And then take the handles and take it out. So that's a simple way. This is the cooling and the 200 degrees. So you can take it out, store it in your box, and put in the next one. Also relevant if you use heating is to have a very poor concentration of oxygen. So higher temperature makes your process more sensitive to pick up oxygen. That filter system has a 24/7 option with 2 filters, and it can remove humidity as well as oxygen and gives you better properties for demanding materials. So I speed up a bit. Next is key market and case studies. Our AMCM systems are, let's say, 30%, 35% in space, 30% in defense, new energy, academia, and medical. This is about the split today. So mostly it's combustion chambers in different sizes, M8, M4, M2, but also for conventional aeronautic hydraulic block for Libya. And that part here is a simplified version of, let's say, Ariane combustion chamber. Also, Ariane has two different, it's a Vinci and a Vulcan device in there for stage 1, stage 2, and the idea is to make these as additive. We also make custom machine, as I said, very exotic one. So here's a machine where we integrated a robot arm to suck away powder, to place some RFID chips or to place other powder. That was for a university. Or we have made a machine with a CO2 laser producing pills, pharmaceutic, special application. And maybe roadmap is a bit misleading. What can we do next? Because it's all based on orders. So if there is no order, we don't produce a machine. We can do machines with this plug-in, what I explained. We can do M450s with 6 lasers. We already have orders for that. And M4K with 6 lasers, whether it's kilowatt or N-light. In 2026, we will deliver first M8K. And the concept for that big machine is also ready to make up to 1 meter machine. So even 12 lasers would be possible. And the journey goes on. Also the beam shaping and light laser called AFX already available with 2 kilowatt now. And I think they will grow in laser power. So that's the capability. And we are a tuning company. So we boost your application. If you have a need, let us know. Whether it's a bigger machine, a more powerful machine, machine with heating or gas purification. There we can also use the ecosystem of EOS. We get process development, software development, and they help us to integrate, for example, Smart Fusion in our system, which was developed there. And so we could take the benefits out of that network and make unique systems. And the business model is we don't have machines on stock. We have to have a PO first. Yes, that's it. Thank you for your attention.